Hi there, my name is Mitch Harlabidis, and in this video we will keep discussing on AP pre-calculus math content. And more precisely, we will discuss about extrema in polynomial functions. There are some rules that we need to follow. Rule number one, between two successive zeros, and by successive I mean one after another. So between two successive zeros of a polynomial function, there is always one turning point, which means that there is always either a local minimum or a point of local maximum. Let's see an example to understand that even better. Let this be an xy plane, and when we say zeros, geometrically, these are the points at which the graph is equal to 0, so this makes them x-intercepts. So between two successive zeros, one after the other, assuming that we are working on a polynomial function which makes it a continuous function, there should either be one point of local minimum or one point of local maximum, at least one. Let's see what that means. Let's say that the graph was somehow like this. Since it passed through point A, since we want that graph to pass through point B as well, which are the two successive zeros, then at some point it has to turn back. So this, in this case, it would have been a point of local max. Similarly, if my graph in another xy plane passes through points A and B, it could have been like this. And this is the local mean. This means that as long as the graph is a continuous one, which in simple words means that we will draw it without raising our pen, then that graph should definitely turn direction at least 1 point. And be careful, this theorem is about the existence of at least one such point. For instance, if we have these 2 points, A and B, it might be the case that the graph goes like this. You see here that this is a local max, this is a point of local mean, this is a point of local max, this is the point of local max, and finally, this is a point of local mean. But in any of all these cases, between two successive x-intercepts, there is always at least one turning point, either that is a local minimum or a local maximum. Rule number 2. A polynomial of even degree has either just a global max or global mean, depending on the leading coefficient. Now, in this rule, we start talking about the presence of a global max or a global mean. Remember that so far we were talking about local max and local mean. And we would say that, let's have this graph here, a local max is the point at which every time the graph looks like an upside down U. So here, let's call these points A, B, and C. Similarly, the graph would have a point of local mean, every time it looks like a U at the vertex of that U, local mean. However, the global max is the biggest value of the local max points and the endpoints. This means, for instance, that in this case, the global max would have been that right endpoint. This is the global max. Similarly, the global mean is the function's lowest value, and we can find it by comparing the smallest of local minimum points or the values at the graph's endpoints. In this case, this local mean down there, it's at the same time the global minimum as well. Now, rule number 2 simply states what's happening with the global minimum or max, and it states that it depends on two things. First of all, the degree of that polynomial, and then the leading coefficient. More particularly, this rule suggests that the leading term is an even number. So it's x to an even power, and it's all about the leading coefficient. Now, this is more related to the end behavior of the graph, because let's take cases. Case number 1. A is positive. So the graph will look like, the function will look like the leading term at least, positive times x to an even power. Considering the end behavior, we would get that as x tends to plus infinity, a positive number multiplied by plus infinity to an even power would result to plus infinity. Also, as x tends to minus infinity, then positive multiplied by minus infinity to something even is also equal to plus infinity. So no matter what, in this case, the graph, either when it tends to the right end or to the very left end, it would look like this. So regardless of what happens in between these two, there should be, for sure, a point of global minimum. So when the coefficient is positive, then it has a global minimum. In case number 2, if A is negative, so it would look like that, x to an even power. With regards to its end behavior again, as x tends to plus infinity, negative multiplied by plus infinity to an even power would have been minus infinity, while as x tends to minus infinity, minus times minus infinity to an even power would still be equal to minus infinity. So in this case, if I were to geometrically draw that, I would begin by the xy plane. This is the x and this is the y plane. We know that at the very right end and at the very left end, the graph moves to plus infinity. So it is somehow like that. And regardless of what's happening in between, whether it crosses or not the x-axis, we know that at some point it should have met its global maximum point. So once again, when the degree of a polynomial is even, and with regards to the coefficient, then the graph of a polynomial function, we are only talking about polynomial functions, the graph of that function has either just a global max or just a global mean, but certainly not both at the same time. Let's move on. Let me clear up these things. And let's move on the third rule. A polynomial of odd degree now has not either a global max or a global mean. And let's see that. So we want the degree of that to be odd. So we're talking about x raised to an odd power. And then we have the leading term. If a is positive, it would look like that, plus x to the power of odd. And now, with regards to the end behavior, as x tends to plus infinity, it would have been plus times plus infinity to something odd. This should have been plus infinity. As x tends to minus infinity, plus times minus infinity to something odd. In this case, that should be minus infinity itself. So the entire product would be minus infinity. And if I want to draw a graph that could represent this information, it would look like this. So as we extend to the right end, it should move upwards without ending, so plus infinity. And as we move to the left end, it should approach minus infinity. Regardless of what's happening in between, you can see that there is no global max nor a global mean. There can be as many as possible points of local minimum and local maximum, but now we are only discussing the presence of global mean and global max. So in this case, it doesn't have any global max or global mean. And the second case, it's pretty much similar to that. If the leading term coefficient is negative, that would be like negative times x to an odd power. So as x tends to plus infinity, we would get minus times plus infinity to something odd, which is equal to minus infinity. And as x tends to minus infinity, we would get minus times minus infinity to something odd, which results to plus infinity. So a geometrical representation of this could be the one following. This is the xy plane. Let's put the end behaviors. As x tends to plus infinity, it moves to minus infinity. And as x tends to minus infinity, it moves to plus infinity. Once again, regardless of the situation in between, it could have as many as possible points of local mean and local max. There is certainly not any point of global max or global mean. And that would be all. Let's recap. In this video, we talked about the presence of global mean and global max in a polynomial function. We connected that with the degree of the polynomial and the sign of the leading term coefficient. And of course, we mentioned in the beginning that as long as local mean and local max are concerned, between two consecutive zeros, two consecutive x-intercepts, there should always be at least one of them. That was all. If you still face any issues, if you still have questions, don't be shy. Let them below. Write them below in the comment section. As always, thank you for watching.